Hello everyone. So in the last lecture we have seen a concept called conservation of momentum, and I had promised you that I will take an example just to illustrate the concept in more details, how to actually apply the concept for solving a real life example. So in this lecture we will see one example that is based on a repetitive application of this concept of conservation of momentum. So in this example I am drawing a gun, or basically a rifle, with the help of which you can shoot bullet. Okay, so this is the bullet that has come out of a rifle. The mass of the bullet is 5 kg, or mass of the rifle is 5 kg, which is a heavy rifle, whereas mass of the bullet is only 100 grams. So let me write it in kilogram as 0.1 kilogram, so that all the units have uniformity, everything is in SI units. So what you are doing is you are holding this rifle in your hand and shooting a bullet with the help of this rifle. The speed with which this bullet is moving forward is 100 meters per second. Such a high speed it has, 100 meters per second. So in a second the bullet will cover a distance of 100 meters. Usually you run this 100-meter race, you know how much time it takes for running a 100-meter race. For an average runner like us, it would take around 15 to 16 seconds to cover a 100-meter race, but the bullet covers it in just a second, 100-meter distance. The rifle has a mass of 5 kg. Now if you have used a rifle, or if you have seen somebody using a rifle, probably police or probably some heroes or villains in the movies, if you have seen anybody shooting a bullet with the help of a rifle or with the help of a small gun, you would be knowing that it has a phenomenon, it demonstrates a phenomenon called as recoil of a gun. What is recoil of a gun? If you are holding the rifle like this and if you shoot a bullet, the rifle recoils back. That means it comes back and it hits your shoulder. That is called as recoil of a gun. So when the bullet it moves forward, the rifle comes back and it hits your shoulder. Now what we want to know is what is the speed with which it recoils back. So I will call it velocity of gun. The speed with which the gun recoils back. So basically it will tell you the speed with which it is going to hit your shoulder back, and the speed should not be large enough, otherwise we will have to increase the mass of the gun even more than this, so that the speed becomes lesser. I mean, you will know why increasing the mass of the gun will decrease the speed with which it recoils back. But there are recoil-less guns which have some additional mechanisms provided in it, so that they don't recoil much and don't hit your shoulder, so that it doesn't get hurt. But we have a simplistic mechanism wherein how does a rifle fire a bullet? How does it do that? It has a simplistic mechanism of spring that is compressed in here. So when you pull the trigger of the rifle, the spring basically gets unwound. Okay, so it expands all of a sudden, and whatever is the bullet that is held inside this barrel of a rifle, this is called barrel of the rifle. This is called the trigger of a rifle. There is a spring mechanism in here. So when you press this trigger, it unwinds the spring and the spring suddenly pushes the bullet ahead. The bullet travels through the barrel and then it escapes and hits the target. That is the simplistic mechanism, simplistic explanation of the mechanism inside the rifle. Now when you press this trigger, the spring exerts a force on the bullet. The spring exerts a force on the bullet, and the spring is a part of the rifle. So when the spring exerts a forward force on the bullet must exert an equal and opposite backward force on the spring and hence on the rifle. Why? Because the Newton's third law says so. For every action there is always equal and opposite reaction. So because that reverse force or the backward force exerted by the bullet on the spring and hence on the gun recoils back, or the rifle recoils back. So that is the physical explanation of this phenomena of recoil of a gun. Now there are two ways of solving this problem. One is to find the force or the impulse basically. So if we are not given the time that is involved in pushing this bullet forward and recoil of the gun, if you are not given the time, you cannot find the force. You can find a product of force and time which is called impulse, like we saw in the last lecture. So one way is finding the impulse that is given by the gun to the bullet, that will simply be the change in the momentum of the bullet, and then saying that this impulse applied by the gun on the bullet should be equal to the impulse imparted by the bullet on the gun. We equate the impulses and get the change in the momentum of the rifle. That is longer way of doing it. But in the last lecture we have already introduced this concept of conservation of momentum, which would prove to be a shorter way of doing it. Rather than going into the impulse, what we will do is we will consider this entire bullet plus rifle as a system. Bullet plus the gun or bullet plus the rifle is our system. Okay, so system has two parts to it. One is the bullet, the other one is the rifle. These are the only two parts in the system. Now, just see if there are any external forces to this system. So we are holding the rifle, but at the moment when we press the trigger and the spring pushes the bullet forward, the spring, it pushes the bullet forward. We have no part or no role to play in pushing the bullet forward. We don't have any role to play there. We don't do like this. We are holding the rifle, and if we want to shoot somebody or if we want to shoot on the target, we don't do this, right? We are not physically pushing the bullet forward. What pushes the bullet forward is the gun. So gun exerts a force on the bullet, bullet exerts a reverse force on the gun. These are the only two forces coming in picture, and that is why there is no external force on the system. Now you might have already understood what I am hinting at. Since there is no external force, what did our law say? Force external on the system, if at all it is there, it should be equal to change in the momentum divided by change in the time. But the conservation of momentum law says that if this is absent, that means if it is 0, then what will I get? Change in the momentum by change in the time is 0, and hence change in the momentum. Now what am I talking about? This is for system, right? So bullet plus gun. For this system, change in the momentum is 0. What is change defined as? Always in physics, change is final minus initial. So P final minus P initial is 0, and that means P final is equal to P initial. We have already introduced this concept of conservation of momentum. That means momentum final is equal to momentum initial. We already introduced it. Now using this concept for the system as a whole, this is for the system as a whole. The momentum of the system final is equal to momentum of the system initial. I will use this concept to solve for the velocity of the gun, the recoil velocity of the gun. Now, just plug in all the values. So initially, what is the initial case? When the bullet is inside the gun, the bullet is not fired yet. It is inside the gun and it is just sitting there. You have not pressed the trigger yet. What is the speed with which you are moving the gun? You are not moving it at all. So the speed of the gun is 0. You have not fired the bullet at all. So the speed of the bullet is 0. So initially everything is at 0 speed. What will be the initial momentum of the system? It will be mass of the gun into speed of the gun initial plus mass of the bullet into speed of the bullet initial. Right? Now, what is the mass of the gun? It is 5 kg. What is the initial speed of the gun? I said we are not moving it at all, so it is 0. Plus, what is the mass of the bullet? It is 0.1 kg into bullet. It is not moving yet, so it is again 0. So 0 plus 0 will give me initial momentum as 0. Nothing is moving at all initially. Now, what is the final momentum? And then we will equate them, right? So, what is the final moment? Final P will be equal. Now the bullet is moving rightward. We have to define our directions because velocity is involved and velocity is a vector. So we have to define our direction. I will take rightward positive. You can take leftward positive and see if the answer matches. It has to now, right? This is not the moment to check. We already had so many lectures where we talked about choosing our own sign convention and the things work out in their own way to give the same answer in either of the sign conventions. So now there is no doubt about it. Now final momentum will be equal to mass of the gun into final velocity of the gun Vg, which we don't know, we want to evaluate, plus mass of the bullet into velocity of the bullet final, which is given. Final in the sense after you press the trigger. So how much will it be? Mass of the gun is 5 kilogram into velocity of the gun is unknown, plus mass of the bullet is 0.1 kilogram into velocity of the bullet is 100 meters per second, and it is rightward, so I'll keep it positive. Now I'll equate this final P to our initial P. What is initial P? It is 0, so I'll just put 0 here. So final P is equal to initial P. We proved it that there is no external force, so these two have to be equivalent. Now I'll solve for this equation. So this term will go on the other side. What will it give me? 0.1 into 100. That will be 10. So minus 10 equal to 5 times Vg, and therefore velocity of the gun is 10 divided by 5, which is minus 2 meters per second. Why minus? Because it is leftward. So basically magnitude of the velocity, if we talk about, it is just 2 meters per second. Why is magnitude important? Because now we know with what velocity is the gun coming backward, and 2 meters per second is basically a significant velocity we are talking about, and that is why the gun will hit hard. So just keeping 5 kilogram mass of the gun will not be sufficient. You will either have to have some additional mechanism to absorb this shock, which is now provided in most of the modern guns. They have recoil-less guns, so they have some additional mechanism which damps this effect. Or you will have to, a simplistic way would be to increase the mass of the gun to say 10 kilograms. So what will happen if I make the mass of the gun as 10 kilogram? The velocity will be 1 meters per second. That is what will happen if I make the mass of the gun as 10 kilogram. If I make it 15 kilogram, it will even reduce. But what is at stake there? You will have to lift a rifle which weighs 15 kilograms. So that's heavy, right? If you want to shoot somebody, you will just go there, and if you start lifting the rifle which weighs 15 or 20 kilogram, then leave apart shooting. You cannot even lift the rifle itself. So that way we cannot, increase the mass of the gun endlessly. So there are some restrictions on the mass of the gun, and therefore we provide some modern system in modern guns. Okay, so this is how the things are done, but the problem is not over yet. We can even further apply this conservation of momentum principle. We haven't yet seen what happens to the bullet. The bullet is fired from the gun. Now it has to go and hit some target. Where is the target? This is the block. So I'm not taking a live person as a target for obvious reasons, but this is a block that is sitting on the floor. The floor is rough. Okay, so what is going to happen? This bullet is going to travel some distance, and then it will get embedded into this box. So basically it will hit the box, and it will get embedded inside it. It will penetrate inside the box, and then it will travel some distance and stop. But since the box is loosely kept on the floor, nobody is holding the box, we haven't put any bolts to stop the box will start moving forward with some velocity. We don't know what velocity. Now let me give some mass for the box. Let me tell you how heavy the box is. So let us say the box weighs 900 gram. That means 0.9 kilogram. 900 gram box. Okay, so it's pretty light box, and what we have to do is this bullet gets embedded into the box. It is traveling with this and this speed, and it has this and this mass. It gets embedded into the box, which is kept at rest. So initial velocity of the box is 0. Initial velocity of the bullet is this 100 meters per second, and it gets embedded. We have to find what is the velocity with which the box starts traveling forward. We have to find that velocity. Okay, so again, applying the principle of conservation of momentum. Look at the system. Now our system has changed. So now that will, tell you the importance of selecting a system. Now the gun is out of the question. It has already recoiled back. It has hit your shoulder. So that's out of question now. What is your new system? The bullet that is traveling and the box which is at rest. That is your system. What is the initial momentum of the system? P initial. I'll say it is equal to mass of the bullet into initial velocity of the bullet plus mass of the box into initial velocity of the box. So how much will it be equal to? Mass of the bullet, which is 0.1, into initial velocity of the bullet is 100 meters per second. Both the velocity is rightward, plus velocity of the box initially it is kept at rest on the floor, so it is 0. So how much will it be? 10. What is the unit for momentum? Momentum is your kilogram into velocity, so kilogram meter per second, right? or it is also equal to Newton second. We have seen in the last lecture it is impulse. And now momentum final, that is when the bullet gets embedded into the box. Bullet gets embedded into the box as shown, and the system of bullet plus box, the entire system of bullet inside a box, the whole system moves forward. We have to find the speed with which the system starts moving forward. It won't maintain that speed. The speed will go on reducing because of the frictional resistance offered by the fluid. But we just want to find the initial velocity with which the system will start. Now, what is the mass of the system? The bullet and the box, they are together moving. So I can take entire thing as a system. How much is the mass? It is equal to mass of the bullet plus the mass of the box, which is 0.9 kilogram plus 0.1 kilogram, which makes it 1 kilogram is the mass of the entire system into how much is the velocity of the system. That is not known. We have to find it. Now equate the two. Why can we equate the two? Because there is no external force on the system. The bullet is traveling forward. It gets embedded into the box. Nobody is trying to stop the box. Of course, there is a friction, but it won't immediately try to stop the box. Once the box starts moving, then only the friction will come in picture. But as long as the box gets embedded by the bullet, the friction won't come in picture. It is not an impulsive kind of a force. Had there been some bolts or some resistances that will stop the box from moving, then we could have had another impulsive force into picture. But there is nobody who is trying to stop this system from moving, and that is why we can directly equate these two. And what will we get? 10 kilogram meter per second is equal to 1 into V. So a very simple equation to solve. So velocity of the system of box plus bullet is equal to 10 meter per second. Very simple. So the box will start moving with a speed of 10 meter per second. Why has it happened? The bullet is so small. It is only 100 gram bullet, whereas the box is 900 gram, relatively 9 times heavier box. But it will start moving with a speed of 10 meters per second because the bullet had a speed of 100 meters per second. And that is what is the power of momentum. Either your velocity is large or your mass is large, the impact is going to be severe. And that is what happens with the box. It starts moving with a speed of 10 meters per second, which is not a small speed. 10 meters per second, if you convert it to kilometer per hour, it translates to 36 kilometer per hour, which is speed of a usual car that is moving, right? So in a second, it will move 10 meters ahead. That is the speed with which the box will start moving. So this is how we can continuously, repetitively apply the same principle of conservation of momentum over and over, and get the velocity of so many unknown things that are happening around us. Now you can, in fact, continue further. I haven't talked about the box when it stops after moving some distance, but that is a simple thing to do. So I am giving it to you as a homework. The box, it stops after, it stops. When I say it stops, you should guess what is the final velocity of the box plus. So it's not just a box, it's a box plus bullet system having a total weight of 1 kilogram or the total mass of 1 kilogram. So the box plus bullet system, it stops moving. That means what will be its final velocity? You have to guess. So when it stops moving, it covers a distance of, let us say, 20 meter. It covers a distance of 20 meter, and it stops moving. With what velocity it has started moving. What velocity will it have when it stops, and what is the distance s that the entire system will cover while moving. What you have to find is what is the average resistive force offered by the floor, right? As I said, the box will slow down because of the frictional resistance offered by the floor. Now you don't know what frictional resistance formula is, but that is not needed. Take it from me. The formula is not needed. You don't need to find the formula for the frictional resistance. You don't need to know the formula for the frictional resistance. What you just need to know is the final velocity of the box, which I have already given you, the initial velocity of the box, which we found out, the distance that it moves through. This all you can use your equations of kinematics to find the time that is involved for this motion. Once you find the time for which this happens, you can somehow, I will not tell you how, but you can somehow find the acceleration that is involved. Once you find the acceleration, you can say mass times acceleration is the resistive force that acts on the box, because force is equal to mass times acceleration. That is one way of doing it. What is the second way of doing it? You know initial momentum of the box plus bullet system. You know final momentum of the box plus bullet system. Change in the momentum, which is final minus initial, change in the momentum divided by time involved, which you again will have to find using the equations of kinematics. So change in the momentum divided by the time involved is again the resistive force that comes in picture in this case. And in fact, that will straight away give you the sign of the resistive force, because final momentum is 0, initial momentum is there, some positive quantity. So final minus initial will be a negative value, divided by time will give you negative force. And why is the force negative? Because it is leftward, it is resistive force, it is continuously trying to slow the box down, and that is why the answer to the force will be negative. So you can either use your momentum, impulse momentum principle for solving for the force, or you can use F is equal to ma for solving for the force. So use any one of these two things and give me the answer for the resistive force that is acting on the box. Okay, this is how we can use the conservation of momentum. Now in the next lecture we will be seeing the concept of equilibrium of a body. Equilibrium, what do you mean by equilibrium? We had in our first law that every body continues with its state of rest or of uniform motion unless and until it is acted upon by an external unbalanced force. That means if you don't apply any external unbalanced force onto a body, the body, if it is at rest, it will stay at rest. If it is moving, it will keep moving. So this state of rest in which all the forces on the body are balanced, this is called as an equilibrium. So we will be seeing what is the necessary condition for equilibrium to happen, and how can we find some unknown forces when equilibrium is involved. Okay, so in the next lecture we will be talking about equilibrium, and some examples that are that are seen in day-to-day life. We'll solve those examples based on equilibrium concept. Okay, thank you.